Hello Algebra 2 class, this is Mr. An. We're going to do the classwork for today. Please open up your book to page 722 and we'll do these three questions first. For number 2, it reads, find the measure of each angle in standard position. If you don't have the notes with you, I have re-uploaded to Plus Portal, but standard position is basically this position. You start with the initial side and then you end with the terminal side. Now I do want to find the measure of the angle, and for the measure, the first thing that you have to remember is the direction. Normally the direction would go counterclockwise, and that would make it positive, but because it's going to go counterclockwise, we know that my angle should be negative. It starts at 0, then negative 90 degrees, then negative 180 degrees, negative 270, and yada yada so forth. But from here in your book, they tell you for number 2 that the angle from this line to this line is going to be 45. So you're going to go backwards 90 degrees, then you're going to go backwards a little bit more to find the answer, and you're done. Number 6 is very similar. You are going to go backwards, so the angle should be negative. This time, however, I'm going to go backwards all the way, past the terminal side. So I'm going to go backwards and not stop here, but go all the way to the end, where it becomes negative 360 degrees, and then go forward 20 degrees. So therefore you get negative 360, and then I went forward, so therefore the plus. And so you get that answer. Number 8, it says sketch each angle in standard position. So this is negative, so we're going to go backwards, and we're going to go 130 degrees. So 0 degrees, 90 degrees, negative 180 degrees, so it must be between these two angles, so roughly here. I do have to indicate the direction, or else I won't know that it's negative. And then you're done. Now, just as a side note to help you with your end review, if it was a positive 130 degrees, just in the other direction. So it should be between 90 degrees and 180 degrees, so roughly here. And make sure you indicate the direction using an arrow. All right, at this point, please turn to page 729. And I'd like to apologize for the audio quality, but I think you'll live. Again, just a reminder, the notes are up on Plus Portal as a PDF file in case you have no idea what I'm doing. Number 1, it says write each measure in radians. So that's what we're going to do. And then express the answer in terms of pi and as a decimal rounded to the nearest hundredth. Right? So we have negative 300 degrees. As noted in your notes, we don't like using degrees anymore because it's an arbitrary number to have a full circle be represented by 360 degrees. So we're going to use what is called radians. To change one unit to another unit, we're going to use unit conversion. So you learned that in Algebra 1, you can multiply any number by 1 and it wouldn't change the value. So that's exactly what we're going to do. The unit conversion rate we're going to use, however, is pi radians is 180 degrees. We learned that for a unit circle, 360 degrees is going to be the same thing as 2 pi. So therefore, if I divide both of these by 2, I know that 180 degrees is the same thing as pi radians. This is a much simpler unit conversion rate than this, so we're going to use this. The reason why you're putting radians on top and degrees on the bottom, however, is so that I can cross out the unit degree and be left with the radian unit that I wanted. I'm going to divide both of these numbers by 10. I get 30 over 18. They're both divisible by 2, and then 3, And so we're left with negative 5 pi over 3. And if you plug this into the calculator, since you know that pi is a number, we get this, rounded to the nearest 100th place. We're going to do this backwards with number 8. We're going to take a radian and change that into degree. So again, you can multiply any number by 1 and have it equal the same value. I'm going to use a unit conversion rate. And 180 degrees does in fact equal 1 pi radian. But this time I'm going to put degree on top. That's the unit I want. And I don't want radian, so I put it on the bottom. Pi also cancels out. This cancels out to 18 and 1. 11 times 18 is 198 degrees, so we're done. All right. Next page, number 31, it says, in which quadrant or on which axis does the terminal side of each angle lie? Terminal side is just basically the side it ends in, as you can see in this picture. But let's start from the beginning. The reason why I chose this question is because you were told in your notes that this is now the radian measure of the axes. So you have 0 radian, pi radian, and so half of that is pi over 2. And so full radian plus a half of it would give you 3 pi over 2. But this is not very helpful for my question because I have a fraction over 3. So what I'm going to do is just convert everything to over 6, since I can make this into a denominator of 6 by multiplying by 2. And therefore I'll multiply 2 on top as well. So if I re-represent 0, it's just going to be 0. But pi over 2 can be rewritten as 3 pi over 6. That makes sense. Pi can be rewritten as 6 pi over 6. That should make sense, since pi is the same thing as 1 over 1. Multiply 6 to both the top and the bottom, and you get 6 pi over 6. Likewise, you get 9 pi over 6. Since my radian measure is 8 pi over 6 positive, I'm going in the positive direction between 6 pi over 6 and 9 pi over 6, so I should end somewhere around here. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. The terminal side is in quadrant 3, so we're done. 41 is very similar, but in 41 I actually want you to draw it, which we already did in 31, but let's just do it as an extra practice. I have 7 pi over 6, so originally it's going to be 0 pi over 2, pi, 3 pi over 2, but as we did in this case, we can rewrite those exact values over denominator of 6, which will make it much easier for us to gauge where 7 pi over 6 is at. So it should be between 6 pi over 6 and 9 pi over 6, so roughly here, and it is going in the positive direction. And we're done. All right, good luck on your end review.